Welcome to another episode of 3-Minute Videos with Nathaniel. Today we will now be solving question 1C of MAT Oxford 2020. The question asks, find the value of this series. Now, you might notice, what are these little tools at the end of these numbers? Well, these are basically square marks. So square numbers are basically numbers multiplied by itself. For example, 2 squared equals to 2 times 2 equals to 4. Let's do more squares. Now, let me ask you a question. What is 7 squared? That's right, it is 7 times 7 equals to 49. Now, what is 99 squared and 100 squared? 99 squared equals to 99 times 99 equals to 9801. 100 squared equals 100 times 100 equals to, some of you might call it a myriad, some of you might call it 10,000. So we'll just put 1 followed by 4 zeros to reduce ambiguity. Now, we can rewrite the series as 1 squared minus 2 squared plus 3 squared minus 4 squared plus plus 99 squared minus 100 squared. Now, we can take the negative of this series, reasons shall be discussed later. And the reasons shall be discussed later should be discussed now, because 100 squared minus 99 squared is easier for most of you than 99 squared minus 100 squared. Because why would you take a bigger square from a smaller square? Now, we are going to use a tool called counters. You may have played with them when you were a little kid. We are now going to use the exact same tools to solve this question. We'll group the terms into twos this time. Squares have an immediate visual relationship in terms of counters. So 2 squared in counters is ... 3 squared equals to ... Subtraction in counters also has a very immediate visual relationship. For example, if you want to calculate 11 minus 5 in counters, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Some of you might take away 5 counters equals to 6 counters left. You know how to use the counters now? Let's solve this question. First, let's calculate 2 squared minus 1 squared in terms of counters. We have a 2 squared square now. This time we are going to take away 1 squared from here. There's another rule to construct these diagrams is to draw a line below the line of counters with no crossouts. Notice that it's equal to 2 plus 1. The reason why is because there are 2 corners on the top and 1 corner on the right. 4 squared minus 3 squared equals to 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We will take away 3 squared from the bottom corner. We'll draw the line again by the rule. Line below the line of counters with no crossouts equals to 4 plus 3. Won't you look at that? Now look at the original series. 4 squared minus 3 squared equals to 4 plus 3. 2 squared minus 1 squared is 2 plus 1. Now, using this rule, 100 squared minus 99 squared is 100 plus 99. We'll put in the ... Have you ever folded a meter stick before? I haven't, but I've seen foldable meter sticks. Basically, a folded meter stick is when the fold mark is at the 5150 cm area. So 100 plus 99 plus plus 51 plus 50 plus plus 4 plus 3 plus 2 plus 1. Now let's align these numbers in the form of a folded meter stick. 100 plus 99 plus plus 52 plus 51. Then we put at the same numbers, 50 plus 49 plus plus 2 plus 1. Now we sum them up. All these pairs equal 101. Don't forget to add in the negative sign later. How many pairs of 101 are there? We can do this by dividing 100 by 2 equals to 50. 50 times 101 equals 5050. Remember we took the negative on the sum earlier. Now we take the negative here. There you have it. This series of alternating sums of squares from 1 to 100 solved using some squares, obviously, and some counters, and featuring an imaginary folded meter stick. See you! Bye!